In July 2026, Brazil's Receita Federal will implement a format update to the Cadastro Nacional da Pessoa Jurídica, or CNPJ. The National Business Identifier is expanding from a purely numeric string to a hybrid, alphanumeric format. Existing numeric CNPJs will not be converted. If a company has a 14-digit number today, that identifier remains valid. The mixed character format will only be assigned to new commercial entities registered after the rollout begins. On the surface, this looks like a localized registration update, a minor adjustment to an onboarding form or a database field. Treating this as a superficial change ignores the complex dependencies within the enterprise. It assumes that if a value can be entered, it can be processed, an assumption that overlooks the validation logic buried in downstream systems. For decades, legacy enterprise systems have been built on the hard-coded assumption that a CNPJ identifier contains only digits. Because of this, systems rely on strict integer validation and numeric-only database constraints to filter incoming data and maintain integrity. Introducing alphabetical characters into this environment acts as a catalyst for failure within those rigid rules. The consequences manifest as halted supplier onboarding, stalled invoicing workflows, and blocked regulatory tax reporting. The coming alphanumeric CNPJJ rollout ultimately serves as a massive stress test for an enterprise's undocumented technical debt. This diagram details the structural parameters of the new identifier, starting with its total length. The total string length remains exactly 14 positions, preserving the historical data footprint of the identifier. The shift occurs in the first 12 positions, which are now unconstrained and can accept alphabetical characters. The final 2 positions, the verification digits, remain strictly numeric. Because the 14-character length is unchanged, the string can bypass basic UI masks and character count validations. However, this very same string will encounter completely different constraints once it reaches deeper layers of the system architecture. By tracing a simulated registration for a new supplier through a standard enterprise stack, we can locate where these constraints exist. The alphanumeric CNPJ successfully passes through the external supplier portal UI without triggering errors. Central database tables may successfully store the record if the target column is already configured to accept text strings. But successful storage is only the first step. In an enterprise environment, storage does not guarantee that every connected application can process the data. The CNPJ is continuously copied and transmitted across entirely decoupled internal systems. Each of these systems enforces its own independent historical validation rules on the incoming data. An identifier considered valid by the master database can still be rejected or corrupted when processed by these downstream dependencies. Consider the first point of failure: legacy validation rules. Regex masks written years ago may strictly enforce digit-only inputs, forcefully rejecting the new alphanumeric string upon receipt. A second failure point exists in API schema definitions. Integration payloads often define the CNPJ field as an integer type rather than a string type. This data type mismatch causes the API gateway to drop the payload, frequently without any notification to the user. A third failure point is found in data processing routines within ETL jobs or legacy spreadsheet macros. These routines frequently use formulas designed to strip all non-numeric characters before execution. These routines silently mangle the alphanumeric identifier, passing corrupted data into critical fiscal systems without throwing a recognizable error. These deeply buried dependencies rarely cause a total system outage. Instead, they result in a slow accumulation of silent operational friction across multiple departments. This friction means blocked invoices, excluded fiscal reports, and manual billing workarounds. This reveals the core technical paradox of the CNPJ update. While the code remediation is straightforward, the discovery challenge is immense. Legacy business rules are frequently buried inside opaque scripts, forgotten stored procedures, and undocumented mainframe integrations. A development team cannot update a validation constraint if they do not know which specific script houses that constraint. Without an accurate map of data lineage, attempting to update the codebase is merely guessing at vulnerabilities in the dark. To manage this transition, enterprise architecture teams must prioritize system visibility. This framework provides a path to readiness, beginning with a discovery assessment. The discovery phase involves parsing source code, databases, and APIs to locate every CNPJ ingestion. The second phase is logic analysis, determining the risk level of each dependency. A failure in a tax reporting workflow carries high regulatory risk, while an error in an internal dashboard may be less critical. Categorizing by risk ensures that engineering resources target the vulnerabilities where failure would result in measurable financial or regulatory damage. The final phase is targeted remediation, where specific validation logic and API schemas are updated based on the previous analysis. Completing this audit well before the July 2026 deadline is essential for maintaining continuity. The primary risk is waiting for the first mixed format CNPJ to reach a production environment and fail silently. The CNPJ expansion is a strategic forcing function to finally map and untangle opaque legacy systems. By auditing the architecture now, enterprises transform undocumented technical debt into mapped system intelligence, ensuring their data pipelines remain resilient against any future format expansion.